Alright, hi there everybody. This is my first video on biochemistry, and I'm going to start with the most ubiquitous of all the reactions, which is glycolysis. So glyco, sugar, lys means to cut. So if you're playing Pokemon, this is your Scyther is going through and he's cutting the glucose molecule in half. And the end is you're going to make for every one molecule of glucose, you're going to make 2 molecules of pyruvate. Okay, pyruvate is this small 3 carbon long carboxylic acid that's then able to enter the TCA cycle. I hope that was as entertaining for you as it was for me. This is my in the science asylum with my walls here that I use to study biochemistry. I highly suggest if you study biochemistry, you too have padded walls, or you might also go insane. My eraser. I'm hoping that doesn't fall on my head while I'm going down here. Alright, so anyways, so glycolysis, you take 1 molecule of glucose, you turn it into 2 molecules of pyruvate. So, some key things to remember about this is it takes 10 steps. Okay? Now, you might be wondering yourself, do these 10 steps really matter? And the answer is, sort of. 3 of the 10 steps matter because those are the 3 steps that where things tend to get regulated. All right, so I'm going to start off and I'm going to draw what is a glucose molecule here, CH2OH, and then for the rest of these, you know, I can't ever actually remember whether the hydroxide groups go up or down. I think it's down, down, up, and we'll say up. 1, 2, 3, 4, 5, 6. All right. So there's your glucose molecule. Now, glucose travels in your blood, and for those of you who have diabetes, you have more of this than other people do in your blood, and that's why people talked about not eating too much sugar, because it's bad for you, and in our modern world, it's just really easy to get sugar anywhere you go, and this is the most basic sugar. All organisms need this for their life. All right, so what happens? The first step of glycolysis, this is one of the 3 steps. There are 3 really important steps you need to remember. This is the first one that's really important, is this enzyme. All right, in most of your body, it's called hexokinase. But inside your liver, and to a lesser extent your kidneys, it's called glucokinase. Okay? And I'm not going to go into, in this lecture, why it matters that there's 2 different enzymes. Just briefly, I'll tell you, hexokinase tends to be more efficient, and it has a higher Km, which means it takes less glucose for it to be utilized to make glucose 6-phosphate. So this is what's important, is you take your glucose, you add on to it, so you use ATP, and then over here you're going to make ADP. So this is adenosine triphosphate. I'm sure you heard about this in like high school biology where they told you, oh, glycolysis and glucose makes 36 ATP, whereas lactic acid, which you build up, only gets 4 ATP. There's a reason for that. I'm going to go into that a little bit today, but not really. So first molecule, you get ADP plus glucose 6-phosphate. Okay? So what happens is this oxygen group, you lose this hydrogen, and you attach a phosphate group onto it. All right, that's step 1. Step 1 really, really matters. Okay? Step 2 is a little bit different. You're basically just going to take this bond and you're going to break it out here, and then you're going to have carbon, and then you're going to actually turn this into fructose 6-phosphate. Okay? So step number 2, you make fructose 6-phosphate. All right? And it's not the most important reaction. It's necessary because there's different forms of reactivity between glucose and fructose. It's a 5-membered ring instead of a 6-membered ring. Nothing crazy. So the first step, phosphorylation of glucose. Second step, going into fructose 6-phosphate. And then your third step, you're going to convert fructose 6-phosphate into, you're going to add another ATP. All right, so this is called an isomerization. This is where you're going to add another ATP, and you're going to make fructose 1,6-bisphosphate. Okay. Now, this matters a fair amount because when you make fructose 1,6-bisphosphate, now you have 2 phosphate groups on your glucose molecule. Okay, and so then what happens is you're going to take this guy over here, this carbon, this one out here that had an OH, and notice when it's not in the ring, it has a higher reactivity. It's easier for them to add the phosphate group on here, so you're going to get a P-O-O-O. All right, so that's your third step, is you're going to make fructose 1,6-bisphosphate. Now, once you have fructose 1,6-bisphosphate, what are you going to do? You're going to split the molecule, and you're going to have 1, 2, 3, 4, 5, 6. So you have 6 carbons. You're going to split it right down the middle, and then you're going to break this bond. And you're going to make 2 things, okay? The first one you're going to make is called DHAP, which stands for dihydroxyacetone phosphate. Oh, that is a long one. And the other molecule that you're going to make is going to be called GA3P, which is glyceraldehyde. Glyceraldehyde 3-phosphate. Okay. Notice at this point we've used up 2 ATPs. There's 1 ATP here, and there's another ATP here. And this is really important because this is called the energy investment phase. Okay, so this whole time doing this, and the enzyme that does this, if you want to remember it, it's called aldolase. Aldolase. Okay, it splits it into 2 molecules. All right. Now, after we've made this dihydroxyacetone phosphate and this glyceraldehyde 3-phosphate, there's a few things. This DHAP can't actually be used for glycolysis. It can't be used for energy in this sense. It can be shuttled off to make glycerol, which can be used to make fatty acids, but we're not talking about today. What's important here for us is this glyceraldehyde 3-phosphate, and so what happens is this bad boy gets converted into glyceraldehyde 3-phosphate. So now we have 2 molecules of glyceraldehyde 3-phosphate for every 1 molecule of glucose. Now remember, earlier I said we're trying to make 2 molecules of pyruvate. Well, you get 2 molecules of glyceraldehyde 3-phosphate. This starts us towards our route of getting 2 molecules of pyruvate. Okay, so your glyceraldehyde 3-phosphate, and then here's a very important step. Oh, I forgot to tell you my other big regulated step. This fructose 6-phosphate to fructose 1,6-bisphosphate, that's super regulated. Okay, this is very, very important because, A, you're using up energy. Okay, you're only going to use up energy if you're going to make money in the end, right? Same thing with like the stock market investments. You're only going to put money into Microsoft if you think that the dividend that Microsoft pays off is going to give you more money in the end. Otherwise, why don't you just spend your money on a vacation and make yourself feel better about your life? All right, so this is actually super regulated. And the enzyme that does this one is called PFK1. PFK1, which stands for phosphofructokinase 1. Phospho, like pho. You're going to a Vietnamese restaurant. Phospho, fructo, like another form of sugar. Kinase 1. It's called a kinase because it adds a phosphate group on, which matters for pretty much any biochemical reaction other than pyruvate kinase, which we'll get to at the end because it actually does the opposite because they didn't know what they were talking about when they were studying. All right, so let's see here. We had step 1, phosphorylation. Step 2, isomerization. Step 3, another phosphorylation. Step 4, we split it into molecules. Step 5, we have our glyceraldehyde 3-phosphate. And here's what's going to matter. We're going to do another phosphorylation. So now this one's a little bit different because you're going to take NAD+, okay? And since you have 2 of these, all right, this is very important. There's 2 of these. So we're going to have 2 NAD pluses, and you're going to make NADH, okay, which is an energy carrier molecule that we can use in the tricarboxylic acid cycle, which we'll talk about later. And then you're going to put another phosphate group on here. So you're also going to add an inorganic phosphate. So you have 2 of these, 2 of these, and you're going to make glyceraldehyde 1,3-bisphosphate. Oh, bisphosphoglycerate. Glyceraldehyde phospho 1,3 GA3P. Glyceraldehyde 1,3-bisphosphate. There we go. So you're gonna make GA1,3B BPG. Glyceraldehyde 1,3-bisphosphate. Okay. Now that you've made glyceraldehyde 1,3-bisphosphate, here's where you're going to do something different. Okay, now we have 2 phosphate groups on a 3-carbon chain. So I have carbon 1, carbon 2, carbon 3. And at the end of each one, there's a phosphate group. Okay, Now this matters because there's lots of energy in those phosphate bonds. So what you do now is we're going to cleave one of those phosphate bonds, and you're going to make you're going to make glyceraldehyde 3-phosphate? No, because you already have that one. You're going to make phosphoglycer. You know what? I don't remember.